All right, so what I want to do is take you slowly through the algebra to solve for a sample size if you are trying to meet the criteria of a particular size margin of error with a certain confidence level. So this is the first problem on our assignment for day 2, Unit 7A, day 2, where we were asked to be 90% confident. So our critical value is 1.64 and have a margin of error. This particular one had a margin of error of 0.08. So when we fill these in, and we also knew that our p hat, our sample proportion, was 0.4. So here was everything filled in with the n. Now, algebraically, the first thing that you need to do is not square. A lot of times I get people who want to square first. The first thing you have to do is divide by that 1.64. Okay, so what I would really like for you to do on these problems is to leave everything in the calculator so that you do not have any rounding errors, because any little bit of rounding on these makes a big difference. So here we go. So that was 0.08, and then we're going to divide by that 1.64. Divided by 1.64. Okay, and then once we have that, then you can see, I'm just going to leave that long decimal there. Now, I wrote it all out on this just so you could see it, but I would not typically do that. Typically, I would just write the equation and then keep all of the math in my calculator and then write out the answer. Okay? All right, so next, to get rid of this square root, we're going to square both sides. Okay? So on my calculator, then I'm just going to square that. And there we go. Okay, once we have that, then here is where I get a lot of people making a mistake algebraically. We want to actually, once we have this point here, we're multiplying by n on both sides. So we essentially have this number n equals 0.24. So it is the 0.24, the part on the right-hand side, that gets divided by this big long number on the left. So here's how we're going to do that. We're going to do 0.24, and then we're going to hit divided by, and then we want to recall the previous answer. Now, if you happen to have you might be able to just arrow up and hit enter to recall that, okay? Otherwise, if you do not have that, then you can put 0.24 divided by the previous answer. And the way you can get the previous answer is by second and the negative sign. And that'll do the same thing. So that'll recall that previous answer. So that gives us 100.86. Because we always need to make sure that we round up on this. We must always round up, because see, 100 isn't large enough to meet the specifications that we want. We have to have enough. So I always, even if this was a number such as like 100.1, I would still round up. Okay, so 101 is the smallest amount that I can have to meet these specifications. Now, let's just show you what one of those looks like with this one here. This one was this. So in our calculator, I'm going to first do 0.025 divided by 2.8. So just wanted to show you what what the rounding does. Divided by 2.58. Okay, so I have that. See, look at that. That is not a number that I really want to have to write down and keep and mess with and even rewrite what that number is. So then I'm going to take this product of 0.38 times 0.6. Oh, let's see. Did I square both sides already? I don't think I squared both sides. Okay, and so then I need to take that product of 0.38 times 0.62 and divide it by that previous answer to get my amount. So I think, oh, I know what happened. I know why. See, look at it divided it by 258. So I knew there was something wrong there. 0.025 divided by 2.58. There we go. And then we square it. And there we go. That's better. And then I'm going to take that product of the 0.38 times the 0.62, and I'm going to divide that by my previous answer. There we go. 2509.19, which of course 0.20, which I need to round up. So 2,510 people is how much I need to sample in order to have a margin of error of just 2.5%. That's a pretty small margin of error, and be 99% confident about that. So that's why I have such a large sample. All right, so hopefully that algebra helped you on how to solve those problems correctly and how to keep all of that in your calculator so you do not have to get any rounding errors.